Alright, we're going to look at functions, domain, and range. On the page after slope on the left hand side, then pause the video and then copy this down, what a function is, what domain and range is. And I'm just going to show you in a graph what domain and range is. So say this is a function. The domain is going to be the set of x, and the range is the set of y. So the range is from the lowest point to the highest point. That's going to be the range. It's your y. Your domain is from the smallest x to the highest x. That's going to be the range for which the graph exists. Okay, so it cannot be somewhere where the graph does not exist. So the graph actually has to exist at that point. Alright, so we're going to take a look at a couple of examples. But just to let you know, for every one input of x is exactly one output value of y. That's really the key thing that you need to remember. For every one input of x is exactly one output value of y. So if I picked a point anywhere on this graph, I'm going to get one output of y. Now it's okay for me to pick another different point and get that same output of y. But what I cannot do is pick one x and find two y's. That's really what I'm trying to say. Alright, so let's take a look at different ways that you can get this question asked, because actually there are plenty of ways. So let's take a look at an example. Let's say that you have these relations. This is a listening check, shading the number 2 in the first parentheses. So your domain will be all your x values, and I'm just going to put them in order. So smallest one is going to be -1, then 0, then 2, 3, and 5. Your range is going to be all your y values, and again I'm just going to put them in order just because I'm used to doing it. So that's a -1, 0, 3, and then you see if 5 happens twice, you're still just going to write it only one time. Then my third question is going to be, is this relation a function? Is this a function? So remember, for this to be a function, for every one input, there has to be exactly one output of y. So I'm going to look to make sure that x does not repeat. So basically, x cannot be the same. This is a listening check. Put a box around the x. Put a box around the x. So I'm looking at all the x values. They do not repeat. They're not the same. So because they do not repeat, yes, it is a function, because for every one x, there is one y. So let's look at a different example. Let's say they give it to you looking like this. This is a listening check. Go ahead and shade in -2 right by the y. Shade in -2 right next to the y. So the domain would be all your x functions. So we're looking at 2, 4, 5, and 9, all your x values. The range will be -2, 0, 2, and 4, all your y values. And then see if this function exists. Remember, for every x input, they can only be exactly one output. So if this is a function, for every x is only one y. But if you look right here, for that one x, it gives you two y values. But remember, we can only have one. So that 5 is going to give you 0 and 2, and that 9 is going to give you 2 and 4. So no, this is not a function, because for every one x, I must get one y. This is a listening check. Put a box around example 3. So let's say you had a linear function looking like this, a straight line. What is the domain? So remember, the domain is all the x values. So do you see that the graph exists for all values of x? So the domain is all real numbers, and that's how we represent all real numbers. Like capital R with another little slash inside. Now, if that's the domain, what is the range? Remember, the range is when you plug in all the x's, what values of y do you get? Do you see from negative all the way to positive? It is defined, so it's all real numbers as well. And then the question is this a function? It's really, really simple to see if this is a function. You just do the straight line test, and what that means is you just draw a vertical line going down, and if it crosses the graph more than one time at any given point, then it is not a function. In this particular function, it only crosses exactly one time, so yes, it is a function. That means only one x value gives you a y. Alright, let's take a look at an example. I'll give you an example. Same thing of the graph, only this time I'm going to make it cross more than one time. So let's say it looks something like this. So again, if this I ask for the domain of this, for where does all the x values exist? In other words, where is there a value for all x? Well, there's an x value starting from -3 to infinity. So you can write that out as x, the domain is x is greater than or equal to, because it is defined at -3, then -3. Then the range is when you plug in these x values, what are you going to get? Well, if you look at the output for the y, the range is going to go from -infinity to +infinity. The graph goes on forever. So the range is actually all real numbers. Then if this is a function, So again, the vertical line test says that all you got to do is draw a straight line vertically. If it crosses at more than one point, okay, then it is not a function, because it's only one y value, but that same x gives me two values. So that's why the vertical line test works. So it is not a function. And that's pretty much it. So let's practice.